Hello, I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. I am presenting lecture series on electromagnetic theory for BTech first year student under engineering physics. This is my lecture 7 of this series. In previous lecture, I discussed about the Poynting vector, Poynting theorem, various properties of electromagnetic waves, and the basic laws of electromagnetic theory. In this lecture, I am going to discuss plane electromagnetic wave in conducting media and skin depth. How the plane electromagnetic wave behave in a conducting media and what are the conditions of conducting media will be covered in this topic. We know that there are some condition of the free space already discussed. Similarly, there are some condition for the conducting media. In conducting media, free charges are zero. Conductivity of the medium is very high, it is not zero. Permeability of the medium is mu, and the permittivity of the medium is epsilon. Under these conditions, Maxwell equation can be written as del dot E is equal to 0 and del dot H or del dot B is equal to 0. Del cross E is equal to minus del B by del T, and del cross H is equal to JC plus epsilon del E by del T. These are the four Maxwell equations for conducting media. Now we will take the curl on both sides of equation number 3 or equation number 4 to know the behavior of electromagnetic wave. So taking the curl on both sides, del cross E minus mu del over del T del cross H. In my previous lecture, I discussed about how to solve this vector identity A cross B cross C. It will be del dot E minus del square E is equal to minus mu del over del T del cross H. Now I will put the value of del dot E from the equation number 1. This value from the equation number 1, this is the Maxwell equation 1, this is Maxwell equation 2, this is Maxwell equation 3, and this is Maxwell equation 4. So this value, this is after taking the curl, this is equation number 5. So the value of the del dot E and del cross H in equation number 5 can be written from the equation number 1 and equation number 4 respectively. So this become del dot E because 0, it becomes 0. It becomes 0 minus del square E is equal to minus mu del over del T. In place of del cross H, I will write JC plus epsilon del E by del T. And it become del square E is equal to minus mu. This is the JC. So it can be written as sigma E. So it is a mu sigma del E by del T, because we know that JC is equal to sigma E. And it will be minus mu epsilon del 2 E over del T square. And it will become like this, plus sign, both sides. This is the equation number 6. So by taking the curl of equation number 4, similarly for vector H, it will be del square H is equal to mu sigma del H by del T plus mu epsilon del 2H over del T square. This is the equation number 7. Now these are the second order differential equation, and the solution of these equations are equation number 6. I am writing again. This is the del square E is equal to mu sigma del E by del T plus mu epsilon del 2E over del T square, and the equation number 7 is del 2 square H is equal to mu sigma del H by del T plus mu epsilon del 2H by del T square. These are the equation number 6 and equation number 7. So the solution of equation number 6, E RT, which is the function of is equal to E naught e raised to the power I k dot r minus omega t. And after solving, we know that after solving, we know that del can be replaced by ik, del vector, and del over del t operator is minus I omega. So equation 6 or 7 becomes del is the ik square E is equal to mu sigma del over del t is the minus I omega E plus mu epsilon del by del t is the minus I omega whole square into E. It will be minus k square E, because I square is minus 1, is equal to minus mu sigma omega E into I plus I square is minus 1. So it will be minus mu epsilon omega square into E. And it become k square E is equal to mu epsilon omega square E plus mu sigma omega E into I. So this k square is, now E will be cancelled out from both sides, and this k square become mu epsilon omega square plus I mu sigma omega E, where k is the propagation constant. K is the propagation constant. And this is, suppose this is the equation number 8, this is 9, and this is 10. So in equation number 10, we will keep this case the propagation constant, and it is a function of attenuation constant and the phase constant alpha plus I beta. It is a complex quantity, and we can write k as like this in equation number 10. So I'm writing equation number 10 again. K square is equal to mu epsilon omega square plus I mu sigma omega. This is the equation number, sorry, it will cancel out. So it is only I mu sigma omega square. This is the k square. And in place of k, I will write k as a alpha plus I beta whole square. And it is a mu epsilon omega square plus I mu sigma omega. A plus b whole square, with the help of a plus b whole square, I will open it. Alpha square minus beta square plus 2 alpha beta I is equal to mu epsilon omega square plus I mu sigma omega. And alpha square minus beta square is the mu epsilon omega square, and the 2 alpha beta is equal to mu sigma omega. These are the equation number 11, and this is the equation number, let us take equation number 11 to this, and this is the equation number 12, and this is the equation number 13. And after solving the equation number 12 and 13, we there is this these are the quadratic equations and we will solve it. So alpha will be omega mu epsilon 1 by 1 plus sigma mu epsilon by 2. Yes, 1 plus sigma omega epsilon whole square, and this is the 1 by 2 plus 1 over 1 by 2, and the beta is omega mu epsilon by 2 1 plus sigma upon omega epsilon whole square 1 by 2 minus 1. These are the values of alpha and beta. Alpha and beta are the constant, represent k is equal to alpha plus I beta. This is the equation number 4 and this is the equation number 5. So we know that the value electric field E is equal to E naught e raised the power I k dot r minus omega t. So we will write, we will put the value of k here, alpha plus I beta. We know it is a vector. So E can be written as E naught e raised the power I. In place of k, I will write alpha plus I beta in dot r minus omega t. E naught e raised the power I alpha dot r, it will be minus omega t, and it is a e raised the power minus beta r. It shows that this is the electromagnetic wave because alpha is the phase constant, propagation constant, and it shows that the electromagnetic waves is traveling, but this factor is the attenuation factor and it is decreasing the electromagnetic wave. So if E is this, which represent the electromagnetic wave, and these are the alpha and beta. So it shows that E is proportional to e raised the power minus beta dot r. So now I am writing about how the alpha and beta convert. Alpha, I am writing alpha again. Alpha is the omega mu epsilon by 2 1 plus sigma upon omega epsilon whole square 1 by 2 plus 1 1 by 2, and the beta is writing beta here, and the beta is omega mu epsilon by 2 1 plus sigma upon omega epsilon whole square 1 by 2 minus 1 power 1 by 2. So for good conductors, it is a condition that propagation constant and the this attenuation constant is equal. Alpha is equal to beta, and we will see it, and the sigma upon omega epsilon is very greater than to the 1. So we will neglect this one. So it become, and this one. So it become alpha is equal to omega mu epsilon by 2, because this one is neglected and one is very small than this sigma, and this one is also neglected. So this 2 1 by 2 become, first of all this will be neglected, and now it will be sigma upon omega epsilon, it will become like this. So after solving it, we will get alpha is equal to omega, this omega will be this, and epsilon will cancel out, mu sigma upon 2. And similarly, it is equal to beta. So we can see that yes, alpha is equal to beta for the good conductor. So for the good conductor, alpha is equal to sigma, which is mu sigma omega by 2. And for bad conductors, bad conductors. Where the conductivity is not very high, then sigma upon omega epsilon is less than to the 1. And in this condition, alpha is equal to omega mu epsilon. And the beta is equal to sigma by 2 mu by epsilon. These are the alpha and beta. Alpha and beta for bad conductors. And as in this equation number 16, we already see that with the help of these alpha and beta, we will calculate the skin depth. So this is the this shows that the how the electric field decreases exponentially due to factor e raised the power minus beta dot r. So this is the cause of skin depth. We will discuss it further. As we know that what is the skin depth? Skin depth in conducting media means when the electric field skin depth is the depth, skin depth is the depth, here is the distance in conducting media when amplitude of EM wave reduces to 1 by E of the maximum value E naught. That distance is called skin depth. So skin depth is the distance in conducting media when amplitude of EM wave reduces to 1 by E of the E naught. What is the meaning? Suppose electromagnetic wave is traveling and in free space. Now it enters into the conducting media. Then the amplitude of the electromagnetic wave start decreasing. Then the amplitude of the electromagnetic wave start decreasing. If this is the maximum amplitude, this is the maximum amplitude of the electromagnetic wave, and this is the distance inside the conducting media. This is the distance in a conducting media. So the amplitude of the electromagnetic wave is going to be decreased slowly. And the distance at which the amplitude is reduces to the 1 by E value of the maximum field is called the skin depth. So this is the skin depth where the amplitude is reducing like this. If this is the maximum amplitude, this is the electric field E, this is the maximum amplitude E naught, and this is the distance at which electric field is reduces to the 1 by E. And this is the distance where value of the E naught is 1 by E. 1 by E means 1 upon 2.7 or 1 upon 3 of the E naught. So this distance is called this is the distance, and this distance is called skin depth. So in this equation, we already see that how the E is reduces to this. It means E is proportional to e raised the power minus beta r. Means if E becomes the E naught, and we can say it is a something constant is over here. So E naught, the electric field E becomes the E naught by E. Then that distance become then that distance is become skin depth. R is the distance, this is the distance R, but this distance R will be delta or is called skin depth when this electric field E reduces to 1 by E of the maximum value, and it become in this way it become E raised the power minus 1 and is equal to E raised the power minus beta delta. In this way we will compare it. It means beta delta is equal to 1, which shows that propagation constant beta propagation constant beta is equal to 1 upon skin depth. 1 upon skin depth. And the skin depth delta already we know that for a good conductor skin depth is, or we know that the alpha or beta is mu sigma upon omega 2. So now it is the 1 by beta, and it will be 2 upon mu sigma omega. In this way, skin depth for the good conductor is under root 2 upon mu sigma omega. So skin depth for the good conductor is defined as the distance in a conducting media when amplitude of electromagnetic wave reduces to the 1 by E of the E naught. These are the references of my lecture: Introduction to Electrodynamics by David J. Griffith, Solid State Physics by S.O. Pillai, and Engineering Physics by S.K. Gupta. Thank you so much for patience listening.